Well, happy Thanksgiving. St. Patrick's Day. I'm just off my days. All right, page 7172, right? Correct? Problem number one. Problem number one, let's see. I'll just go over a couple of these. So it looks like 2, 5 is one of the points. Whoa. Preston, did you move the projector again? Did you move the projector on me again?
No.
It's okay if you did.
Not this time. Last time, yes. Not this time.
All right, I see how it is. I blame Ben then.
He's going to take it. It's like 10:15.
All right, hopefully that's a little closer. All right. -2, 5. 1, 0. All right. So, someone asked me yesterday, why are we doing so many of these? This idea of the shifting of graphs applies to all graphs, not just parabolas. Okay, it literally, any graph, the same rules apply. So problem number 1, A, you have, so you have left 5 and up 2, right? So honestly, right 5, thank you. And up 2, so 1, 2, 3, 4, 5, up 2. So for the most part, this is what this one's going to look like. I'm not going to draw every point. I just want to, you can see the shift of that. And then we have so I know it moves up, but what does the negative out in front of the f at x do? What? Change it.
Makes all y negatives. Does it change the x? Flip the x-axis.
Flip it.
Flip is the x-axis.
Okay, so this is going to change the y value as well as move it up 3. Let's see if we can make that work. It changes all the y values and it moves it up 3 from the new change. Yeah.
Do you flip it and then just move every point from the flip swap of the graph?
Yes, that's what I was thinking.
Okay.
Let's see if we do that. So this is like the point 3, -7. Oh wait, go to my original. Jeez, I don't know why I have 2, 5. So that's going to become 2, -5, right?
Yes.
And then what does it do?
Go up 3.
Up 3.
And then I do 1, 3, 5.
Yep, and then do 1, 3, 5. I like it. So I'll just do those. Oh, that worked out well. Oh, whew, I thought it was going to be much harder. Blah, blah, blah. What's the next one? It says, oh, it's that other one. F at -x. So C, F at -x minus 4. Well, I know the whole thing's moving down. What did that one do?
That changes. X values.
So let me ask you this. I like what you're saying. It changes all the y values. Does it?
Wait, it changes all the y values.
It changes all the x values?
I thought it changed all the x values.
X values? Yeah, we're plugging in at, changing all the x values. And then we're moving it down 4. So this -2, 5 is going to change to what?
Positive 2, 5.
Positive 2, 5? And then moving it down 4. And then as Gage said, you get the 1, 3, 5 to go with. Okay. Is that right? Huh. So, a little different to look at sometimes, right? So it's going to be the same concept. So when you have the curved ones, identify, a couple of points that you can definitely see. Don't take something that, finding a point like here is not really good because it's somewhere on that line. I don't know exactly where. So find it where it exactly crosses when doing the rest of the problem. So on 3 and 5. How do you feel about this? Seem okay? I'd say if you're starting to get stuck on some of them, definitely write the rule down that you know. And so when I'm grading your test, if I saw, like on the red, if I saw that you had right 5 and up 2, and then I look at the graph and you're off a little bit, well, being your thought that had the right 5 and the up 2, that means something. So go ahead and put it in and create the rule. So what was the rule for the blue? Excuse me, the green?
Change the Y.
Change the Y.
So,
The opposite Y value.
op, y, and flip, and up 3. And this one changed
The X.
all x changes. And then down 4. So that rule means something. It's a good thing to have it there. I know I didn't assign you, I don't think I did. Did I assign you 7 and 8? Down to the bottom? Okay. Can we do 7 and 8? Let's do it as a class, please. Let's see what we got. Number 7. We have y is equal to negative 2x squared minus 12x plus 7. Says give the vertex, the y-intercept, and the x-intercept for the quadratic. Okay? Was your question? No? Okay. So to find the vertex first, we need to resort back to our negative b over 2a, and then you plug it in, right? So I'm going to get negative 12 over 2 times negative 2. So that's negative, that's positive. So I get 12 over negative 4, which is negative 3. And then plug the negative 3 back in, plug it in there. That gives you negative 2 times 9. And then plus 36 plus 7, so that's 18. Negative 18 plus 36 plus 7. So that's going to give me 18 plus 7, so that's 25. So 3 comma 25 is my vertex. They had asked for that. The y-intercept. What is it? Tell me it is a point. Y-intercept.
It's 0, 25.
Almost. I agree with the 0.
Negative
7.
5.
What? Not negative 25.
Oh wait, you look Y-intercept. 7.
7. So my C value tells you the y-intercept right away. Remember that? God bless you. And then the last one says, find where it crosses the x-axis. So a couple of tools that are in our category. Let's see if we can factor it. Let's go old school. So my dream number is, negative 14? Which means I have positive and I have negative, right? Then the factors of 14 are 1 and 14, 2 and 7. Will any of those work to add up to give me negative 12? Well, 1 and 14 and 2 or 7, if I add them up, whether one's positive or one's negative, get me to negative 12. No. So the x-axis, we can't tell on this one. So we could say that it is prime, but a better word to go with is we know that they are irrational roots. Okay? The reason we know they're irrational and so negative 325, that's going this way 3 and up 25. And then so it's way up here, but the parabola opens down. So being it opens down, being it was 25 above the x-axis and it opens down, it will definitely cross. So they have to be irrational. I-O with a dot above the O. E-I-E-I-O. Let's see. Give the vertex, y-intercept, and x-intercepts. Got it. 8. Y is equal to x plus 2, x plus 6. Let's go with the obvious. Almost.
-2.
There you go. So the x-intercept is going to be at -2, 0 and -6, 0. So remember, you set each of those equal to 0, and then you create it as a point. So that's the x-intercept. In order to find the y-intercept, what you have to do is you have to multiply this out. So I have x squared plus 2x plus 6x plus 12. So x squared plus 8x plus 12. So what's my y-intercept then?
12.
What 12? 0, 12. Good. Okay, and then if I'm finding my vertex, now that I have it multiplied out, I can go to negative b over 2a and plug it back in. Or I can say, what's halfway between 2 and -2 and -6? It would be -4. And then if you take -4, you can plug -4 in here, or you can plug -4 in here, or you can plug -4 in here. Your choice, -4 plugged in here, like -4 plus 2 is -2. -4 plus 6 is 2. So that's going to give me that. And there's my vertex. Okay? Feel okay? So we've covered a lot with parabolas. It's a parabola is a second degree polynomial. It's a quadratic. There's a lot of different names that they give it. And they're all legitimate names. And it becomes, where do you know and when do you know to go to your knowledge of these to do them? And I can't answer the how do you know when to go to these at all times? When am I going to go? It's just good that when you see something in factored form, it's easy to find where it crosses the x and y axis. When you have something that is in standard form, meaning ax squared plus bx plus c, we can use that to find, start finding the vertex with negative b over 2a, plug it in. And then there's that one way that you have vertex form. That you need to realize sometimes it's given to you as a gimme, but not everything is obvious to find. Okay? So take a couple minutes, take a look at 1, 2, and 3. See if you can factor those. So I will tell you 1 and 2 you're factoring, and 3 you're solving. Why is that?
Equals 0.
There's an equal sign. So try 1, 2, and 3. See if you can get through them. as you're working through those, you can double check up here to see how it worked out. So for 1 and 3, I just kind of saw it factor real quick. If you're doing it the longer way, you should get the same answer as well. Any questions on 1, 2, or 3? Kind of a review. Some of you might have slipped a little bit, but perhaps it came back to mind, going, "Oh yeah, I remember doing that now." Can I move on? Good. All right. Okay, so general form or standard form is going to basically mean the same thing. Y equals ax squared plus bx plus c. So some things that we know about this. If you are in general form, some tools that are in your back pocket is you know to go to the negative b over 2a, plug in for the vertex. You also know that 0, comma c is your Y-intercept. And then you can pattern graph, which would be a times 1, 3, 5. If a is negative, 1, 3, 5 can be negative. So that's kind of a go-to. So if you see something in standard form, a thought that goes along with it as far as the problem solving, the critical thinking, heck, any of the key words that people like hearing. Let's shock people now. The 21st century skill in math is doing this. But guess what? The 20th century skill was the same thing. But now people are like, no, this is a 21st century skill. Yes, it is. Good. and so is, I don't know. So that's just some ideas of where you would go. And what does PI mean? Plug in, yeah. So that's the in and out of standard form. Okay, and yes, you could look at the example, but I'm pretty sure you're okay with looking at that. Now, I want to modify the intercept form a smidge because I don't like something that they have in there. But we're going to put it up here. Intercept form. And they have it listed like this. Okay, now this is what I don't like. I don't like the H and the K because H and K refer to the vertex in vertex form. H and K up here are not the vertex. Okay, so I would like you to change these. Maybe make this x sub 1, maybe make this y sub 1, or x sub, x sub 2 or something. X sub 1, x sub 2. I just don't want it to be the h and the k, because the h and the k indicate the vertex, and this does not indicate the vertex. But when you're in intercept form, so let me rewrite this so it's a little neater. And I'm using x sub 1 and x sub 2 to refer that we are dealing with different variables. So x, x1 are not the same, x, x2 are not the same. Those x's are the same. When you see this, this will allow you go x minus x1 equals 0, x minus x2 equals 0, and solve, and this tells you where it crosses the x-axis. Which can be referred to as roots. Okay? A is your growth. So you have your A times 135 still. So that's still the same. But then the last part of this is you need to, once you have your 2 points, what is between your 2 roots is the x component of your vertex. And then you'd have to plug it back, this back in. Between your roots is the x component of your vertex. Okay? Well, what's halfway between 1 and 2? 1.5. So a vertex doesn't have to be at a nice whole number. We leave it as a whole number so you don't get hung up on, you know, a decimal or fraction. And I think sometimes that might be a disservice because everyone gets used to, you know, numbers coming out nice and rounded, but then you might have had a science teacher at some point saying, oh, this is related to this type of concept in math, and you're looking at the science teacher and you think they're on crack or something because you got some decimal that's, you know, 16 digits long, and you write the whole thing out, and they're like, no significant figures. You're like, what do you mean? And so, never happened to you guys. I always used to tell my teacher, but this one's more exact. No, it isn't. And I always thought I was right, and I later found out I was wrong. So, it is what it is. There's part of me that. So, intercept form, it allows you to find your roots. Halfway between those roots is the x component of the vertex. You have to take that x component, plug it back into the original equation, and solve it. The a value is still going to dictate whether it opens up and down in the growth rate. Okay, so these are all familiar items, I would hope. And then we get to the vertex form. Which is y is equal to a x minus h quantity squared, comma k, where opposite inside, same outside, is how you find your vertex. So this is nice because it's given to you. But what are some things that you don't know about the parabola when it's in vertex form? You do not know where it crosses the y-axis. You do not know where it crosses the x-axis. Okay? But the nice thing is, in vertex form, you do this, and then you can pattern graph using a times 135, and that's going to get you a lot of points. And honestly, you know, we're asking for 5 points a lot of the time, but mathematically, it's acceptable to have 3 points if one of them is the vertex for a parabola. Okay? So h comma k is your vertex. The pattern graphing works well. In order to figure out where it crosses the y-axis, you would have to multiply out the whole problem. In order for you to find where it crosses the x-axis, you have to multiply the whole problem out and see if you can factor it. Okay? And those are all things that might not work. So where does it cross the y-axis? Multiply all out. Where does it cross the x-axis? Multiply all out and see if it factors. So that could be a lot more work, but just just giving you some ideas. Okay, down below it says, given the equation in standard general form, give the vertex, y-intercept, and the x-intercept of the quadratic function. Okay, we've done that quite a bit. On the back. On the back says, given the equation in factored form, give the x-intercepts and the y-intercept and the vertex. So again, we'll go through that. So write the quadratic equation in the best form suited for the given information. Okay, so I am on the back side, and I'm at example 1. We have a vertex at 2, 1, and a y-intercept of 0, 5. Okay? The vertex is 2, 1. So what letters do the vertex go with? Nope. Oh, what's that? H and K. Okay, so that's an H, that's a K. The y-intercept goes with which value? It goes with a C value. Thank you. Okay, so we have the vertex, HK, and the y-intercept. So our standard form is y equals a x squared plus bx plus c. So the only thing I could plug in right there would be my c value. Does that look like a good equation if I can only find the c value to find everything else? No, let's not do that one. If I do the intercept form, I don't know if that's going to get us anything. H and K, not there. C, not there. So what about vertex form? What values do I know up there? I know an H and a K. So I'm going to put what I know right now. X minus H, so X minus 2, quantity squared plus K plus 1. I like what you're thinking. Write 2 up 1, I got it. But I somehow want to figure out, I want to see if I can figure out what my A value is. The A value is the unknown right now. But I have X and Y in there as well. Okay, hang on. I think we can approach this a different way. What values are these? They're H and K, which are also X and Y. Do you agree?
Yes.
I've already used these. What values are these? It's a C value, but it's also X and Y. Do you agree with that? Well, the C value tells you where it crosses the Y-axis, right? But it is an X and a Y value. It's a point, right? So what if, I've already used these. These are taken care of. What if I use these? And I plugged in here. I don't know A. What am I calling X? 0. All right, let's do a little math. 5 equals A. What is 0 minus 2? Negative 2, and that's squared plus 1. What is negative 2 squared? 4. And I'm going to change the order to become 4A plus 1. Wait, does that make sense? Is that okay? 5 equals 4A plus 1. All right, so if I solve this, if I subtract 1, this is going to give me 4 equals 4A. And then A equals what? Huh? 1. So if my A value is now 1, my A value is 1. Oh, look at this. Here's my equation. Done. Huh. Well, there's no reason to solve for it. I mean, technically, I guess we could multiply the whole thing out. I can go x minus 2 times x minus 2 gives me x squared minus 4x plus 4 plus 1. So it gives me x squared minus 4x plus 5. See if you could factor it. Don't know. But where are you at?
Huh? No, I'm sorry. I was just doing like a thing, but I'm just trying to like follow along.
Okay.
Sorry.
Are you multitasking in here again?
Yeah. Did I say that out loud?
That happens. Okay. So, we go through the process. Can we use this? Can we use this? Can we use this? So look at example 2. Can I clear?
Yeah.
A parabola with vertex. Okay, so this is example 2. You have a vertex at 4, 4, and it goes through the point, this is some random point that they're giving you, of 2, negative 4. Okay. So let's go through our things. Y equals ax squared plus bx plus c. Can I use this one knowing the vertex in one point? No, there's nothing I really know. I know hk, and then I know an x and a y. So I guess with this x and a y, I could plug them in, but it still leaves me a, b, and c. That's kind of weird. Okay. Factored form. So I know an x and a y. I know an x and y and an x and a y. I don't know if that's going to help me. So then we go to the vertex form. A x minus h quantity squared plus k. What are some values you know? H and k and y. So if I take all of those and plug them into this, what is the only letter left that I didn't know? A. All right, so let's plug in what we know. I got negative 4 equals A, don't know, x2 minus 4 squared plus k. You guys see where that all came from?
Yeah.
So h and k, x and y, let's solve it. Subtract this 4, bring it over here.
Well, why did you score 4?
I did the inside the parentheses first, 2 minus 4.
Oh, okay.
So negative 8. That's a good question though, Mac. Order of operations, awesome. Divide by 4. So I get A is equal to negative 2. So now I know A equals negative 2. I know this. I'm going to plug my H and my K in. I'm going to leave X and Y alone. This is my equation to my parabola. So far, vertex forms work twice for us. Huh. I don't know. I bet you they'll give us some that won't have just the vertex form. A parabola. A parabola with vertex negative 1, 4 and a y-intercept of 0, 5. Now, this will be my last example because I know you guys are excited about it. Values I know. This is H, this is K. That's my C value. But that C value is also an XY value like that, isn't it? So let's keep that in mind. So y equals ax squared plus bx plus c. You know what? We definitely know c to be what? You okay with this? Now h and k aren't listed up there. H and k aren't listed up there right now, are they? Well, what are h and k as a point? It is a vertex. What is h and k though? What? Yeah, x and y. That's x, that's y. So let's see. Y and 4 go together. A, I don't know. X squared, negative 1 squared, plus, b times negative 1. Oh, darn it. I thought it was going to work, but now I have a and b left over again. Shoot. I know that so I thought we might have been able to figure that out, but that's not going to work. So I'm going to go back to this. AX minus. Go back to this, and then we can plug in. Let's forget this being that and that. We have h and k. So I have 5 equals a, don't know, x 0 minus h, which is going to be plus 1. Why is it plus 1? I bet you do. There, good. Because that's already negative 1. If you plug that negative and negative here, it becomes positive. Plus k. What is that? Yeah, negative, negative, sure. But you know minus minus is going to be plus, right? But totally, if you want to write that, I like it. So 5 is equal to, that's going to be 1 squared. So I get 1a plus 4. Oh, that's all this is? Really? Man. So a is equal to 1. That's it? Jeez. Went through all that work for nothing? What is this craziness? There's my equation of that quadratic. You guys ready for some homework? Dude, no. Look. Let's have you guys do let's do this. Page 69. Do 12, 13, 16, 17. That should be good. 4 problems. That work out? So guys and girls, if you need to make up a test or a quiz with me, where do you need to go? Research Math Science Resource Center. It's in the testing center. And I know it's open today, but it probably won't be open tomorrow. So then that means that Monday, Wednesday, Friday next week it should be open, okay? I put it over there. I just don't know. My job, I'm kind of going all over the place now. It's going to go a little crazy. I just missed you. Like I come walking in, like a kid named Mac 2 just came around. I'm like, when did you get here? Oh, like 3 minutes ago. I'm like, honestly, I should have seen you in the parking lot. Like it was like I missed you by like split second. I'm so sorry, but it's over there now in the math science thing. So okay.